This is the last video for the stoichiometry section. This is on a topic called percent yield, and we're going to define percent yield as the amount of something that is actually obtained divided by the theoretic amount multiplied by 100, or to put it in simpler terms, what you got divided by what you should have got times 100. And this is something that students use on an almost daily basis. You have an assignment that gets a score of 22.5. The first thing that the teacher gets asked is, how many points was this worth? Turns out it was worth 25 points. Why do you want to know? Because you want to calculate your grade. You go 22.5 divided by 25 times 100 equals 90%, and most students are happy with that grade. So think about it. The 25 points are the points you should have got, the theoretic amount. The points you did get, the 22.5, is the actual amount you got. So following the amount that you actually obtained divided by the theoretic amount, or what you got over what you should have got, you get the 22.5 over 25 times 100 is 90%. Your grade is a percent yield. You know how to do this. In chemistry, the theoretic amount, the amount that should be made, is what we've been calculating using stoichiometry. That's the theoretic amount. Then you run the experiment. You measure the amount you really got, and that's the actual amount. Then you just plug those numbers into the equation, multiply by 100, you have your percent yield. And the percent yield can be greater than 100, less than 100, or equal to 100. So let's jump in and do some calculations. A student allows sodium metal to react with chlorine gas. Based on the amount of chemicals used, it is expected that the reaction will produce 46.5 grams of sodium chloride. This is the theoretic amount. Turns out when they weigh the sodium chloride, they only have 41.3 grams. What's the percent yield? The theoretic amount, 46.5 grams. The actual amount, 41.3 grams. So you take your equation, plug in the amounts, and you get 88.8%. Let's go to a slightly more involved problem, but it's just as easy. You're given 45 grams of butane 2-ol, and it's allowed to combust with an excess of O2. You make 42.6 grams of water. What's the percent yield? You need to do the normal stoichiometry. So set up the balanced equation, and here it is. Now, set up the correct if-then statement. If I have 45.0 grams of the butane 2-ol, then how many grams of water will I make? Step 3, convert if grams to moles, and when you do that, you end up with 0.607 moles. We're going to use the mole ratios to get the moles of the then. The ratio is 5 to 1, so we should produce 3.04 moles of water. We multiply the 3.04 moles of water times 18.015 grams per mole, because moles times molecular weight equals grams, and we should produce 54.8 grams of water. So the theoretic amount is 54.8 grams. The actual amount is 52.6 grams. We're going to take our percent yield formula, plug in the amounts, and we get a 96% yield. Okay? One more slightly involved problem, but once again, it's all the same. So you have this problem. You get the potassium iodide reacting with the chlorine to produce potassium chloride and iodine. And you've got 158.73 grams of potassium chloride at the end. What's the percent yield? Set up the equation. Now, when we take a look at the equation, we notice that we have values for both of the reactants. So we need to determine if there's a limiting reagent. We've got 2.1500 moles of this. The chlorine has 1.253. We set up the ratio using the chloride for the Z. Z is 1.0750. That means chlorine is the excess reagent, because 1.075 is less than 1.253. So once again, chlorine is the excess reagent, which makes the Ki the limiting reagent. So I'm going to circle that because all the stoichiometry is based upon that. So I need to know how many moles of potassium chloride I'm going to make. Set my ratio up, solve for Y. Y is 2.1500 moles. So I put that over there. Moles times molecular weight equals grams. So my theoretic amount is 160.28 grams of potassium chloride. The actual amount I got was 158.73 grams. Percent yield is actual amount divided by theoretic amount times 100. Plug the values in. I get a 99.033% yield. So to review, the percent yield is the actual amount divided by the theoretic amount times 100. The actual amount is the amount you get from the experiment, what you got. The theoretic amount is the amount you calculate from stoichiometry, what you should have got. The percent yield can be greater than, less than, or equal to 100%. So that finishes up the section on stoichiometry.